Mm, mm. Then let's open up add a little tool. Mm, mm. Oh, start there today. All right. Mm, mm. All right. Put it up there. Yeah. Mm, mm, mm. When the Soviet Union. Mm, mm. All right, let's get some good thoughts on today. So last week we focused on solving equations that have been solved before in kind of, and I'll write it up, I'll write it up a little later, but the big summary, sort of the big place we ended up was, or what's the, what's the word, what's the terminology for that? The big picture, was that if equations have like terms, we solve them like we've always solved them, just get x by itself. If equations don't have like terms, then we figured out that one, you're never gonna be able to get x by itself. So instead, what we ended up doing is setting it equal to zero, factoring and setting those factors. Um, so a lot of those equations we solved last week were quadratic equations, they were squared equations. So this week we want to go back and focus on quadratic functions. And we're gonna start by just doing some stuff you've done before, and we're just gonna add on to it. And we're gonna kind of finish as we go through both today and Thursday, by again doing stuff you've done before with quadratics, but now we need some of those new equation solving techniques to kind of get us to some of those answers. Uh, but let's start, like I said, let's start with what we started, what we did. So what you did before, what you guys just did very well on the test, is something like the following. So I'm going to ask you to graph, in some cases, but I'm going to ask you to graph say x equals, let's do x minus 2 squared. Let's do minus, no, let's do plus. So x minus 2 squared plus. So I'd like you guys to take just a couple minutes to think about time. Graph that, and then give me the usual things that we've been doing, domain, range, x, 7 points. What's that for? Yeah, so that's what, I mean, last week I said that second assignment, yeah, it didn't happen. So it's like, and I'm not like mad, but I'm just saying, like I said it 2 or 3 times in school. So if you weren't the only one, there's like 3 people that message me about it. Yeah, so
figured it was the same. I
Yeah.
wanted to, I probably, yeah, I just forgot it.
Mm. 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 Sorry, I did put that. Let's see where y'all. These brackets. Give me the, so it's the X and Y values, or the X values that I'll show. Let's 0 through 4. Why did you change 0 through 4? Not sure, maybe.
Why?
Okay, the Y's are just not too much, okay, good. So tried a couple negatives first, and they were just really huge. Usually when we get nice little 1, we get something true, we get nice little balanced numbers. As far as the Y values, and we tend to get, we try to find the ones where they're at least less than 10, so we try to graph them. So they ended up at 0, 1, 2, 3, 4. Did anybody choose any? What else did y'all choose? Yeah, it goes too far. Okay, yeah. So -2 through 5, so it's 0 through 4 seems to be kind of cool. So when you plugged in 0, what did you get? 5. What about 1? 2, 3, 4, 5. Perfect. Okay. So we can graph that out. So 0, 5, 1, 2, 2, 1. So we get a nice little parabola that looks like this. And hopefully the transformation that's expected. So even before you started graphing, looking at the equation, what were the transformations? What did you notice that's that? Right into another one. Perfect. So good. All right, so then there are the 4 things that I kept asking y'all about first 5 weeks or so. So we'll do those, and then I'll show you kind of what we're going to add on for not like this one, but like this week. So domain, what's the domain? Yep. Infinity. The one? Yeah, it's a positive infinity. Perfect. Yes. Good. Very good. What about the range? Yeah, it's gonna be a square bracket. 1, 2, to positive infinity. So we're going up. It's good. What about x-intercepts? Does not exist on this one. And y-intercepts? 0. Good. Okay. Easy enough. All right, so then the things we're gonna start, so these are things they're only gonna ask for parabola. Basically, there's actually a couple other functions you can ask this for, but usually in these books, they only ask it for a parabola. So what they'll ask this week is they're gonna ask you for the vertex of this parabola. And so vertex just word that comes from geometry where they first studied parabolas. But every time we've drawn a parabola, it's either been a U facing up or down, right? And so there's been this sort of higher low point. It's either valley or top of the hill. But that's your vertex. So it's just a fancy word for sort of that middle. It's either here. And so when they ask for the vertex, like any of these other points, they want you to give the full explanation. So what would the vertex be here? Vertex is 2. Way back in for the 3rd week, when we first started looking at graphs, one of the things we talked about is that not all the graphs that we look at, but a lot of them end up having symmetries. So symmetry was that idea of basically like naturally when you look at them, you see sort of on the table you see repeated values, but more importantly, visually what you see is things match about the shape. With sort of different types of symmetry that we saw, but for the parabola, sort of maybe an odd, badly asked question, but where is the symmetry from? Where do you see symmetry? Yeah, we kind of cut it in half. And it matches exactly on both sides. So that cut in half, literally what it is your mind already has the invisible line there It's not part of the graph, but still see it because it helps you helps you kind of parse what's going on with the graph, that shape. So what we're gonna start doing, so for this week, when you graph this, they're gonna want you to draw in that invisible line. And you're gonna use you use a dotted line to do that. But you're gonna want to draw in that invisible line, and there's a name for this line. This line is called the axis of symmetry. Axis is just a fancy for line that you rotate or have symmetry across. When they ask for the axis of symmetry, then what they want is they want the equation of this kind of vertical line that you have in your mind. That's a ghost, but not really part of the graph. So this line is a vertical line. So thinking back to like the first, I think it was like the first lecture day of class. How do you write the equation for a vertical line? X equals, yes. So a vertical line is always x equals and then whatever the x value is. If you think it's, you can tell visually too, if you think about just this line, this vertical line, every single point on this vertical line has what x value? Yes, x value of 2. So in some ways, you can think of this line as literally all the points that have x equals 2. So that's my equation, x equals 2. So you're going to start giving them this axis of symmetry with specifically parameters. You technically do these same two things with a absolute value graph, B, because it has the same symmetry. You couldn't do it with an x cubed. So you don't have the same type of symmetry for other things. So they don't ask. That's
And it was
not with this class now, because it's not common. Good. What other questions do you guys have then? All right, so you'll actually see about half your homework honestly is graph something like this. So like, that's what I'm saying is you guys actually, I mean, this is really easy too, the vertex axis symmetry. So you literally already know how to do half your homework without me teaching you anything. It's just a rehash of graphing and transformations that you guys have done. Let's write down those transformations too. So some of the questions will ask you to write out the transformations like you guys did for your other homework and for the test. So how would you say, what are the transformations? Yes, one, right, and right two, perfect. All right. Let's do this again. This time the function is going to look like this. Let's do x squared. So I guess the first thing is, so there's something I sort of want you guys to see, learn from doing this. But I do want you to try to do it. So I want you to try to go and graph this. See if you can get all the same stuff. All the same stuff. Let's think you're getting, how many people are getting repulsive cars, like, don't work as well. Yes, yes, yes. Okay, all right, so let's look at that. So like I said, this actually would be that, so we're gonna look at some of your results, but my main point in the next 5 minutes, 10 minutes, is actually to try to figure out why this doesn't work as well, even though we know it should. It's a parabola, it should look and work the same way. And then we're gonna look at how to kind of solve that issue. So. The markers are nice today, that's okay. And what are some of the values y'all are getting at this table? Correct. Okay, so the thing is, there's a good reason, so none of what you guys have done on your paper is actually wrong. So give me what you have on your paper and kind of talk about why this is coming up weird or different. Okay, so you put a -1, you got 6. I think Denise said it should be a -6, yes. -2. I think -2 is not be 0, but it could be. Let's be 4. What is there? Got 8. You said you plugged in 0.
Yeah, that I mean,
0 should give you a -10, but yeah, but it is kind of weird. What else did you all plug in? Did anybody plug in 1? I think it
Well,
should be -12, but it's, 1 should be -12. What about 2? And if you didn't plug in 2, that's fine. So let's go with what we have here. Because this is what I saw in a lot of papers. So what's weird about this? What are we not getting that we're expecting to get? What's weird? Tell me your thoughts. Yeah, so it's not symmetrical. We kind of don't have another side. Right now, we don't have another side to start at all. Was that the only thing that y'all thought was weird? If that's the only thing you thought was weird, that's fine. So if we, kind of like we talked about, when we still graphing, so I know it's gonna be a parabola, and I only seem to have one side of it. So then we just gotta pick some other values. So pick a 2, pick a 3, yes, too much here, but so try plugging in a 2, a 3, and a 4. So I'll give you just a minute for plugging in a 2 and a 3 and a 4. Setting in. So are we getting repeated about it? Well, I'd say, let's kind of see what you got in. You plug in a 2, what do you get? So it is an x squared, so we should expect that. So it's a good question. It's an x squared, you know it's a parabola and it has symmetry, so we should get that. So when you plug in a -2, you get, or sorry, +2, you get -12. What about 3? -10. 4 gives you -6. So notice that we are getting repeated values. What are we maybe missing here though, compared to what we need? Yeah, we kind of don't have the vertex, and we didn't have a word for that before today, but whatever you want to call that bottom or top point, notice that we don't have that. So usually what we have is sort of a point in the middle with repeats after that. We don't have that. Now, if we want, we could try to start graphing some of this.
Like +2x. No, I mean,
Yeah. So let's start with the graph and I'll talk about some of the problems. Not the problems we're running into, the problem we're gonna have finding some stuff. Just from quality. This is something go down quite a bit. So. Some points we actually was up to. -1, 6. So -2, 0. -1, -6. 0, -10. And 1, -12. And then 2, -12. 3, -10. 4, -6. So like we said, we're missing the vertex. So the first problem we're running into that, so this is just in general, not about the way that it sits, but when we were doing transformation before, I would tend to, this one was up 1, right 2, all my ups and rights, everything that moved vertex, I tended to do whole numbers. But I don't have to. My ups and my downs, my movements left and right, up and down could easily be decimals or square roots or whatever really I want. One of the problems we're running into is start looking at parabolas and quadratic equations in general, your vertex isn't always going to be on a nice thing. So you wouldn't pick that up from picking x's and then working out y. Now, again, if it's written this way, I won't find this way yet, but if it's written this way, you can actually see it. So like here, we would see that this would right to would end up 1. So you literally could see the vertex before you even start the problem. You could see that the vertex was going to be 2, but 2. But my question then back to you guys is, can we see the vertex here? Or are these numbers telling me left and right, up or down? So there's the big difference, or kind of the first big point on the way that I've written this quadratic versus this one, is if you don't have that parentheses squared setup that we got used to, if it's written like this, x squared, x, basically it's a standard form, but we kind of looked at that right at the end of last week. Then none of these numbers tell you left, right, up, or down. They do not tell you transformation. You can even see that from this. we don't know where the vertex is, but the vertex is obviously lower than 10. So this is an even 10 down. So that's the first thing to kind of realize about this. So you still can graph the same, you can pick X values, but you are going to be missing a couple pieces. And none of these numbers tell you anything about transformations. This one was nice enough that you can see the y-intercept, you can see the x-intercept. If you kind of kept guessing, you could find the other x-intercepts here. But the other thing that happens often with other equations that are written this way is your x-intercepts and your y-intercepts also may not be clean. So in reality, a lot of times your x-intercepts and y-intercepts are decimals, or their square roots, are things that just don't look really nice. And that also means it would be hard to graph on, because it would be hard to quantitate. So we can still finish out this graph, but what I want you guys, so if you picked a 5, you'll get a 0. But what I want you guys to really get out of this is that we can graph this the old way, but we're not going to find all the information we want. Usually out of these graphs. So when they give you this problem, not only in this homework, but when we kind of look at this problem going forward, instead of asking you to graph this first, they're going to ask you to find a couple of these key points, the x-intercepts, the y-intercepts, the vertex, these things that you guys have been finding kind of for 3, 4, 5 weeks now. They're going to ask you to find those things first. And you'll see once you find those, it won't be a graph, but it'll be a sketch of the graph. But more importantly, they're going to ask you to find them first, because we got to figure out a way to find those numbers exactly, even if the graph kind of doesn't give us those numbers nice. It's the other key one that I want to make sure is over you didn't see when I'm trying to graph this. You're still responsible for an exact intercept, exact y-intercept, even when the numbers are nice. Question is how to do it. So we're basically going to continue this problem over here. Before we finish out the graph, we're going to go back and find x-intercepts, y-intercepts, etc. We're going to find those exactly first. So let's look at the x-intercepts. And we've done this before, not with this equation, but we've done this idea before. So back at the end of the second week of class, we were using the graphs before that to find the x-intercept, and then that Thursday in the second week of class, I kind of threw to you guys, I kind of said, what happens if we don't have the graph, or if the numbers aren't nice? How would we find the x-intercept? And so what do you guys remember? What do we know about an x-intercept that allows us to find it even if I don't have a picture? Setting the y has to be 0. So remember, we talked about every single x-intercept you've ever seen and ever will see has y values. So even without a picture, I know this part of my x-intercept exactly. And so if I know this part and I have the equation, how could I go back and find the x? Set your y equal to 0. I'm going to plug 0 in for g of x here for y value. So I'm going to plug 0 in there. Once I do that, notice that you can go ahead and solve this, and this looks a lot like what we just did last week. So, and that's the comeback, that's the come around. And we needed to do this last week so that on parabolas, like on quadratic functions in general, you can actually find things. We need to now solve this. Then, yeah. So we're gonna have to do, that means notice that we don't have like terms. So like I was talking about at the beginning of class, this means you're gonna have to go and factor this. Tetra factor is equal to 0, but once you have that, you have your x. So let me have you guys practice though, what you were doing last week. So You'll see basically the rest of the problems this week, so the final stuff is just gonna be practicing what you just did last week. So I'll give you all a couple of minutes to do back to this, and work through to a solution. See what you want here. So captain this would be pepper. Yeah, no, wait, yeah. Fine, no worries. So yes, you should have ended up with x minus 5 times x plus 2. And then, yeah, we set each of those equal to 0. So we do end up with x equals 5, x equals -2. And so how would I write the x-intercepts? Yeah, good. 5, 0, and a -2, 0. So just remember to write them as the coordinates. It didn't happen as much in this class as it did my other two, but on the test, again, you guys did really well on the test, so there wasn't like a lot of consistent things overall that a lot of people missed. But if there was anything sort of consistent, so it was just the way, like a lot of this last test was about syntax, the way things were written. Any points, whether it's an x-intercept or vertex, etc., those always they're coordinate, they have an x and a y value. So some people wrote just the x or the y values, and I knew what you meant, so I only took off a little bit for that. But good. All right, so that's x-intercepts. So again, before you even started this table, you could have figured these two out to begin with, and we also can figure out y-intercept. What do I know? What do I know about a y-intercept? Yeah, the x equals 0. So again, without a graph, without a table, I still can know this. And so what do I do to find the y-intercepts? I'll do 0 for x. So we'll have 0 squared minus 3 times 0 minus 10, and that's easy enough, it's quick enough. What does that gonna be? 0. It's gonna be -10. So my y-intercept is 0, -10. So like I said, we actually did this the second week of class, and I think it was third week too. So we already knew how to do that. We just didn't know how to solve this equation. Now we just. The other thing that they give you an equation in standard form. Usually they're gonna ask you to find these before you even graph it. So the other thing they're gonna ask you to find the vertex, which will also give us axis to symmetry, but the vertex. Now this is the thing we don't know how to do. So I want to go back to this picture we have so far of our graph. And like you guys told me, like I kind of commented, we don't have the vertex. But visually, I mean, does it seem clear that the vertex is obviously there? Yeah. So it definitely seems to be there, we just don't know exactly where, right? I want to give you guys two ways to kind of find this vertex. One's going to be if you're a problem solver, intuitive person. It actually makes it really easy. But if you're more of an equation procedural person, I'll also give you that way to do it. But let's just look at intuition problem solving. So we do seem to have a parabola, and the vertex is somewhere down here. I don't know exactly where, but it's somewhere down here. And parabolas are symmetric. So think about, you can do that with any of these points that we found, but let's look at the two x-intercepts. So we just found those as well. Since the parabola is symmetric, so there's a line down the middle that cuts it in half. Then where would you expect the vertex to be in terms of like the x value? Where would you expect the vertex to be in terms of like the x-intercepts? Say it again. Okay, so don't give me, I'm not looking for a number, don't give me an answer on what. It should be right in this. But because a parabola is symmetric, it's split in half. One way to think about the vertex is even if I don't see it, I know it's exactly in the middle between any 2 points that have the same y value. You guys are telling me about all these repeated y values that we're getting. So any 2 points that have the same y value, I could just find the x that's halfway between them. That would be the x for my vertex. So if you already have this table, you could do this with some easier numbers, but if you don't, if you just have the x-intercepts, that's still true for the x-intercepts. The x-intercepts both have a y value of 0, so my vertex should be halfway between my x-intercepts. So let's look at those numbers for the x-intercepts, -2 and 5. How would you find halfway between -2? Just practically, how would you do it yourself? Yeah, so we're gonna add them all together and split it, so we need to find the distance between -2 and 5 and split that in half. So what is the distance between -2 and 5? When you find distance between two things, surprisingly, that's the same as subtract. You don't have to write it out this way, you can just think of it in your mind, but I'm gonna write it out this way so you have something you can follow. So 5 minus -2 gives you 7, and what's half of 7? 3.5. So the vertex is gonna be 3.5 between or away from either one of those points, doesn't matter, 5, -2, however you wanna do that. So what is, if, let's say I started at -2, and I move up 3.5, where do I end up? 1.5. So my vertex, the x value for my vertex is gonna be at 1.5. And that's a way that you can find the vertex. Like I said, this is more of the problem solver, puzzle solver way. But this works every time. As long as you have your two x-intercepts, really any 2 points with the same y value, then we do this and it works every time. Well, I want to see, does that kind of jive for everybody? Is there anybody that they're like, I understand that, but I couldn't do that on the homework plan. So like I said, this is more the puzzle way to do it. Another way to get this though, so let me give you kind of an alternative here. Let me make sure. Get another marker. Damn. So another way to do this, so we just, at the end of last Thursday, we talked about the quadratic formula. So the x value for your vertex ends up being just the front part of that quadratic formula, -b/2. Because the way the quadratic formula works, that plus or minus, it gives you the x-intercepts. Like this is the middle. So that's by having plus or minus, this literally becomes the middle of those two. So, but just as a short method or short explanation, -b/2a gives you the x value vertex. It's just as well. Like in this case, what's our b value? Say it louder. Are you saying -3? Yeah, it's the -3, perfect. And what's our a? Yeah, so since there's nothing in front of the x squared, what's the number that we can sort of staple in front of there for thinking about multiplication? 1. So my a is 1, my b is -3, so this is -3 over 2 times 1. But that's the same thing, that's 3/2 or 1. Either way, you get the same. So, but if you're more of a procedure person and you just want one formula that gets you the x value every time, it's gonna do. Then the y value. For the y value, there's no special trick to this actually. Once you know the x value, not just for a vertex, but just for any point. If I know the x value, how do I find the y value? Going back to like the first second week class. I know the x value is there. But that's for x-intercepts and y-intercepts. So the zeros are for x-intercepts and y-intercepts. So if you're not talking about an x-intercept or a y-intercept,
Do the same thing. Like, the distance.
not for y-values, no.
The relative.
It is. Yeah, so we're finding values, so this is good points to bring up. Vertexes generally don't have zeros for values, or at least they're not guaranteed. X-intercepts are here, y-intercepts are guaranteed have zeros. So what you guys are thinking of as x-intercepts, they will always have zeros. Nothing else on a graph will always have zeros. But that's a good distinction to make. So like all those things that you're thinking of as ways to deal with, to get the zero, do not apply to anything other than x-intercepts and y-intercepts.
Would it just be anywhere, any y value?
Not moving at X is,
Guys, if you have an equation, and I give you the x value, what do you do to find the y value?
Oh, you see, oh, you put it, yeah.
So that's all, you just plug it in.
I'm more
Yeah,
thinking
you guys
as
are
a
aware
bear.
of it. Yes,
Okay.
but this is why I was trying to tell you, this is not a special thing. So you'll see this a lot, but you'll see this a lot as we go through like more of the math here is. You know, the new thing you're looking at is gonna have one special new thing and the rest of it is old hat. It's just the old skills that you already have. But that's the way math works. You're always building off of what you learned. You're never you'll see, honestly, I can tell you, I haven't literally taken all the math classes. There's rarely a topic that you get introduced to in the math class where everything's. Usually it's 10% new, 90% old. Anyways, so yeah, you guys are aware. So once you have the x value, plug it into your equation. And that'll tell you the y value. Because that always tells you a y value. What's that gonna do? I think it's lower than that, actually, because 1.5 squared should be 2.25. Yeah. It should end up being 2.25 minus 1.5 minus 10. You'll end up getting negative 12.25 ounces. My vertex is 1.5, negative 12.25. So again, so if they give you quadratic using standard form, you're gonna have to do this to find the vertex. Because generally the x value is not gonna be some nice number. All right, so without seeing a picture, you plugging things in. You can figure out x-intercept, y-intercept, vertex. If this is my vertex, what about my axis of symmetry? What would the equation for axis symmetry be? X equals 1.5, good. Good, so we kind of have all of this figured out. So then what you guys will see on your homework is then they'll ask you to do a sketch of the graph. So let me just talk about their sketch really quick. When they ask you to sketch the graph, what they want you to do is mark the x-intercepts, the y-intercepts, the vertex, and then the computer will draw the. So that's kind of what they prepare. But it's also like sketch, the word sketch, like, so when you're drawing, what's a sketch versus a picture or an exact drawing?
Like a rough practice run.
It's kind of a rough practice run. So they're using that word really truly in the sense of what it means. That even if you didn't go through and do that whole table, if you just did these 4 things, then if you marked them and drew you would have a good rough practice run on what this looks like. We have the vertex now, so we can mark that. So 1.5, 12.25, and notice now we can get the full graph. Very nicely through. VR graph. And then they'll ask for the rest of the stuff they do, domain, range. So I'm gonna have you guys tell me domain, we'll just have you, well, now that we have the graph. So even with the sketch, the other nice thing about the sketch is the sketch gives you enough information that you can answer domain range. So I'll just give you guys a couple minutes, tell me domain, tell me range, and now that you have the picture, tell me the transformations. They'll also see about that. So I'll give you just a couple minutes for that. Yeah.
I told you things I did before, told you how I used to be. Would you go on with someone like me? If you knew my story word for word, had all my history, would you go on with someone like me? But if it already had shattered, it can be where I would with someone like you.
So what did y'all say for domain? Yes, infinity to infinity. Indeed. What about range? Square back. Yes. To infinity, good. And then what would you say the transformations are on this? Yeah, transformations. So this is gonna be down 12.25 and right 1. Basically, once you have the vertex, that's either. Very in that's a lot. So you guys can go on to this for majors, but if you went on for physics, chemistry, engineering major, finding the vertice ends up being crazy important because it just tells you so much information. It tells you axis, tells you transformations, and tell a lot about the system you're looking at, but I know what it is. Okay. So that's a good start. So we'll come back Thursday and we'll just do, honestly, just do more of these. We'll do a couple more of these. Where, yeah, just a different pattern or whatever. It's so. All right, just see y'all then. I think what did I? All right. But I just did that on.
Sixteen. Oh, I, you know. I picked the part. Okay.
Arthur,
See, those fine, so I can do the first one. Rather, I can go back and.
Oh, yeah, yeah. Yeah, I see, yeah. Um. Yeah, I'm sorry, I guess I should have named them, but they should come in order for you guys, so I guess I just thought everybody would pick up on which one was which. Um. Me. Let me do it now so I don't, because I will forget.
Thank you.
You're welcome. Okay,
I just misunderstood what to do and.
Okay.
But yeah, thank you so much.
okay, you're welcome, no problem. All right. Later. I totally get that. Totally get that. That's that. Get that. Totally get that. No worries. No worries. In the future, that. In the future, trust my words and words over and over the machine. Change things, such things. That's right. That's right. So. To change things, Mr. Dirt. Change. But I can just tell you. Let's. Just my word over a machine. that. No. Share the picture. So just moments. Just have it. Just moments of question. Sometimes I have to change something. But I can just tell you that's one that. Hmm. Hmm. And, hmm. 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 Still 50-50. It's no different than most presidents. I mean, hmm. Okay, yeah, we gotta post about this. This is mm, mm. It's just Mm, 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 mm. Oh,